Hey, Earth Science class. These are notes for chapter 22, the next chapter here that we're working on. We're going to look at the A section, which is having to do with the sun. So reasons why God made the sun would be for us to be able to have a marker in the sky to mark the hours of the day. Also helps us to know seasons because of how high or low that it is in the sky. There's a location in Europe called Stonehenge that was built with rocks and structures. People look at it now and think, oh, what is that for? Is it just for decoration? There is a connection here between Stonehenge and the sun and being able to mark seasons. Sun's diameter, about 109 times larger than Earth, 93 million miles away from Earth. It's definitely something that we look at and need. About 93% of the sun's energy is given off in the form of electromagnetic waves. These are waves that we can't see, but we can take advantage of, and we'll talk about these in a few minutes. The part that we can see would be the visible spectrum. The visible light comes in the wavelengths of deep violet on one end of the spectrum to deep red on the other end of the spectrum. Ultraviolet wavelengths are shorter than the deep violet. Infrared are waves that are longer than the deep red color. We can't see either of these, but we have pieces of equipment that can. And it's believed that certain animals can see these while we can't. Other bands that are part of the electromagnetic spectrum would be radio waves, X-rays, gamma rays. Again, we can use them, tap into them, even if we can't see them. We have pieces of equipment that can. Okay, the sun's color. Sunlight is most intense in the green, yellow, red region of the spectrum, and our eyes are most sensitive to green and red light. Okay, the sun is made up of at least 79 of the 92 natural elements that we find on Earth. 98% hydrogen and helium. The sun has an interior core where nuclear fusion of plasma is going on. And that's what gives it the tremendous amount of energy that we can benefit from. The sun's structure, in terms of the interior, has what's called a radiative zone and a convective zone. They're in constant motion, where what we're looking at on the surface is just kind of constantly changing and moving. The surface is referred to as the photosphere. About 4,800 to 6,000 degrees Celsius is made up of granules, which, looking at your book, it kind of sort of looks like, to me, like kernels of corn that make up the surface. Sunspots and solar flares are a part of the surface. The sun's structure also has what's called a chromosphere, which makes up its atmosphere. The temperature is going to soar as you go up in it. The sun's atmosphere also has spicules, and they're structures where there's a release of energy out from the surface. The corona is a location where there's prominences, and there's a coronagraph. That's a piece of equipment that can visualize and watch that section. There are particles of solar wind that are given off from the sun, and they actually influence our atmosphere. They have an effect on sometimes our ability to hear radio or whatever. Sun's activity, sunspots are cooler than their surrounding areas, and that they may last for about a few hours to a few months. The sunspots also cycle through on their activity, and as was mentioned with the solar wind, sunspot activity is also known or been visualized to affect the Earth. The sun also rotates. It does not stay still, and its mass does not rotate at the same speed. Kind of like if you were watching a water balloon, if you're turning it, the fluid inside of it is going to be turning and speeding up and slowing down and crashing around inside of it. The sun's activity, solar flares, are something that are a part of materials coming out of the sun there. The moon's structure is different. When we look at the sun gives off light. It's a star. It's producing energy and spreading out that energy throughout the whole atmosphere. So the sun is going to be the ultimate source of energy. If we did not have that, we would not be alive. So that's where we're going to stop for today.